Why would I make a banned hypnotic sedative in my garage, and what's even the deal with it? Well, in the early 1830s, a guy called Justus van Liebig discovered a sedative so powerful and effective that it quickly became everybody's favorite general anesthetic and treatment for insomnia. This stuff worked so well that you could begin liking it a little too much, which along with being reasonably toxic, got it banned for medical uses in most of the world. All in all, it's just such a weird substance resembling these whitish heavy crystals with an intoxicating smell, kind of like rotten mango, and its name is Chloral Hydrate. Now, why do I want this stuff? Well, for one oddly specific reason, which is making a powerful insecticide called DDT. This potent white powder, banned by the Stockholm Convention, kills all bugs on contact, has a controversial history, and for some reason, making it is a very popular request on my channel. But amateur chemistry, isn't making chloral hydrate a really bad idea? You see, in my beautiful country of Poland, you can just buy this stuff without any licenses or permits, and since I make this video only for educational and demonstration purposes and will use all chloral hydrate I make for synthesizing DDT, I guess it's fine. The reason why I don't just buy chloral hydrate is that it is prohibitively expensive, and buying something that I can make myself on a channel about amateur chemistry is just missing the point. I figured making chloral hydrate will be a fun challenge to do before I graduate from school and move out of my garage lab to make videos full time. Now, back then I had no idea what I was getting into, resulting in the most draining, frustrating and frankly dangerous project I ever attempted, containing the most sophisticated reaction setup on the channel, and I gotta say, I didn't hate Liebig nearly enough back when I started. But I am getting ahead of myself. How does one make chloral hydrate? Well, if we look at its chemical structure, we can see 3 chlorine atoms, 2 carbons, along with some hydrogen and oxygen atoms. Assembling them all like this is pretty damn tricky, and you'd imagine that doing so requires some exotic chemicals. Turns out that not really, and in his original synthesis, Liebig started from literal alcohol. He used pure ethanol, which is what makes things like vodka or beer what they are. Making it into chloral seems way easier than it should, as it means simply exposing it to ungodly amounts of chlorine, which is a literal war gas. This chlorine isn't what you see on the pull aisle at your local hardware store, rather it is in its pure, elemental form. This greenish, heavy gas smells like death and can easily turn your lungs into something resembling a paste. All in all, making sleep crystals from alcohol and World War I warfare wasn't on my bingo card this year, but here we are. Synthesizing chloral looks weirdly easy when written out like that, and I didn't know it at the time, but this process has a big flaw, which Liebig never seems to account for, and which cost me a month of my life. Before getting to that though, I had to source the ingredients, starting with alcohol. I theoretically could just cosplay a moonshiner and make this stuff myself, but while I plan to do something like this in the future, I decided to just buy it. Still, having basic knowledge like how to make alcohol is incredibly useful if you'd like to rebuild civilization, for example, which brings me to something I've been diving into lately. It's called The Ultimate Guide to Rebuilding Civilization, or simply the book, and it's made by this group called Hungry Minds, which is a big international collective of experienced artists and scientists. It's not like your average, soulless history book, instead being a beautiful visual journey filled with detailed descriptions of every major invention that got humanity where it is today. First off, the production quality is just incredible, with this premium art paper, a beautiful hardcover, and over 400 uniquely illustrated pages filled with a mix of modern engineering and medieval art style. Many chapters of this book really surprised me with their easy-to-follow descriptions of complex topics, even from a chemist's perspective, which can really inspire to think bigger about the things we take for granted. Hell, this thing even has a whole section about making pure alcohol from scratch. I mean, how amazing is that? The book also has this whole hidden quest buried deep inside the pages, a kind of secret puzzle for you to find as you read, which adds a whole other layer of mystery to it, and to me is like a chef's kiss to this beautiful work of art. The book is already a bestseller and has raised over $2.3 million on Kickstarter, so whether you're into science, art, or you're just looking for a unique gift or the perfect coffee table piece, it's definitely for you. If you want to check it out, there is a link in the description and my QR code here on the screen. You can also use the code CHEMISTRY to get 10% off your copy, which is a hell of a deal. Anyway, the alcohol I have to buy for making chloral isn't like what you drink, and don't get me wrong, I would love to pour some vodka into a flask and call it a day, but since it's mostly water, it just wouldn't work for this. What I need is dry, pure ethanol, and since they don't sell that at the liquor store, I ordered this bottle containing 99.9% pure anhydrous ethanol. Considering its low price of $5, however, I wasn't so sure about that. That's why I decided to set up a little test using these lovely blue copper sulfate pentahydrate crystals. I got some onto a heated dish, making them slowly dehydrate, changing color to this dull gray. This makes anhydrous copper sulfate, and to check for water in my alcohol, I just poured some onto the crystals. If it contains any water, the crystals will turn blue again, but even after a few minutes, nothing happened. This was very nice, and I could officially check ethanol off my chloral shopping list. I now have to take care of that whole war gas thing, since if I want to turn, say, 100 grams of ethanol into chloral, I'd need to generate around 230 liters of chlorine gas, which is a monstrous and straight up unhinged amount. Chlorine is not something the humble online supplier sells, and I have to make it myself. Luckily, there are a few ways to do that in the lab, all starting from hydrochloric acid. This stuff is reasonably cheap, and I was able to buy 5 liters of technical grade 33% hydrochloric acid. For anyone curious, if you see technical grade written on something, it's just the supplier saying it's dirty without having to feel guilty. That's why my acid, which should be colorless, has this ugly yellow tinge. Still, for making chlorine this is fine, and this stuff is definitely acidic enough, letting off these invisible corrosive vapors that turn a litmus indicator paper deep red. To turn the acid into angry chlorine, I need comparably angry chemicals, and the only ones like that I have are potassium permanganate, calcium hypochlorite, and trichloroisocyanuric acid, or TCCA for short. They all react with hydrochloric acid to release chlorine, however, considering the absurd scale of this project and my limited budget, I really wanted to choose the cheapest option. That's why I sat down and did the math as God intended, coming up with this beautiful chart. I expressed the chlorine generation efficiency of each method as the percent amount of chlorine atoms generated per a single hydrochloric acid molecule, and the potassium permanganate route turned out to suck the most, sitting at an ugly 62.5% and being by far the most expensive. The calcium hypochlorite route is better, being cheaper and releasing 100% of chlorine from the acid, but it's nonetheless dwarfed by a whopping 200% efficiency of the TCCA one. Now, what's so special about TCCA? Is it some military chlorine releasing agent or something? Well, kind of, since TCCA is manufactured for the sole purpose of releasing chlorine, however not for the military, but for your pool. This stuff is in most pool chlorine products, which neatly solves the cost issue, and I was able to buy this kilo of TCCA tablets from the hardware store. Funnily enough, I will need pretty much all of it, or roughly 850 grams, as I want a 25% excess of chlorine for my reaction, and since these tablets are quite chunky, I decided to crush them up a little. For that, I employed the bag and hammer technique, which is exactly what it sounds like, and apart from making my garage smell like a public swimming pool, it dealt with all the tablets quite nicely. I figured that I might as well grind them up while I'm at it, and for that I used this blender. Now, from your perspective, pulverizing the TCCA went just swimmingly, but behind the scenes, half my lab got covered in TCCA dust. 2 months later, the place still smells like a pool, which slightly annoys me, but I at least managed to turn all my TCCA into this fluffy powder. I divided it evenly across 3 big flasks and wetted each portion with some water so that I don't risk anything overflowing later and have good contact between the reagents. This was also beyond messy, but the chloral shopping list is now complete, which is good progress, and this marks the time to start worrying about how I am actually going to make this stuff. The main thing I had to figure out was how to force everything to react just like I want, and like most problems in chemistry, it is best solved by slamming tons of glassware together. After hours of designing the apparatus and trying to account for any potential disaster, I came up with this monster. It looks kinda intimidating and is actually the most complex reaction setup I've ever made for a video. It consists of three main parts, the first being the chlorine generator, housing 1 TCCA flask at a time, along with one equivalent of hydrochloric acid contained in a pressure equalized addition funnel, which vents the created gas into this tube here. It then goes into this wash bottle filled with anhydrous calcium chloride to dry it and remove any stray acid droplets. This clean chlorine then enters the main reaction chamber, which is a two-necked round bottom flask sporting a stir bar and sitting in an ice bath. It contains 100 grams of ethanol and is the core of this whole chemical orchestra, with everything else carefully supporting and maintaining what goes on inside. One example is this fancy DIMRAF condenser, and using it is me giving the middle finger to Liebig, who also invented a condenser, which I personally think is trash. Anyway, you may also notice this whole other section on the right, and it's basically a gas scrubber on steroids. Its job will be neutralizing all the corrosive gas generated by the reaction, and it's way more sophisticated than what I'd normally use, but I really wanted to do this thing right, so I included this inverted funnel to protect against suckback and a cool liquid vortex for efficiency. Setting it up was quite something, as I had to whip out my box of sodium hydroxide, dissolve a bunch of it in water, store the resulting corrosive solution as I did all the prep the day before, and obliterate my background in the process.
Oh no! God.
This neutralizer should spare the life of my fume hood and a few birds, which is really nice, and overall, putting together this whole apparatus felt like testing all my chemistry skills at once. Sadly, what really held me back was plain old lack of budget, and I had to get really creative with what little glassware I had on hand, so instead of a nice chlorine inlet, I crafted this cursed thing. It's a glass pipette I bent using a blowtorch with its top wrapped in more Teflon tape than I'd like to admit, all stuffed inside a PVC tube also wrapped in Teflon tape so that it makes a relatively airtight seal with one of the reaction's flask's necks, hopefully stopping chlorine from escaping. Speaking of chlorine, it first had to fight its way through all the air inside the apparatus, pushing it out of the gas trap, and slowly giving everything this lovely lime green tint of death. As chlorine contacted the ethanol, an array of reactions began taking place, and as I stood there anxiously watching over everything, I couldn't help but wonder at the magnificent chemistry happening before me. The first reaction going on right now is the gentle oxidation of ethanol into acetaldehyde. I could theoretically skip this step and start from acetaldehyde directly, but since it boils at just 20 degrees Celsius, starting with the much more chill ethanol and sacrificing some chlorine to oxidize it seems like a decent deal. This acetaldehyde formation is also why I need to have everything really cold at the start, since otherwise my yield would get yeeted out into the gas scrubber. Anyway, as the chlorine kept coming, the second stage of the reaction began, and here a molecule of chlorine brutalizes one of acetaldehyde's hydrogens, swapping it for a chlorine atom and generating hydrogen chloride. The antimony helps chlorine react faster and at a lower temperature, which… wait, antimony? Element 51? What? You see, I was pretty desperate for this reaction to work, and based on vibes and a single sentence somebody wrote on Wikipedia, I decided to grind up a gram of what seems like the most random element and add it to the mixture. Antimony is supposedly a catalyst for the whole process, making everything go faster, and you can actually see it going into solution as it reacts with chlorine. This stuff should allow me to work at lower temperatures, which is nice since adding every new chlorine atom to the acetaldehyde molecule gets harder and harder, requiring more hellish conditions. For example, the first chlorination takes place just around room temperature, but the second one requires decent heating and gobbles up chlorine much faster. Around this time, everything also begins getting quite cloudy, and that's because there is a second layer forming. You see, this reaction is not one of these nice ones where everything reacts in distinct steps and there is always a bit of everything here at once. This means that even though all ethanol should now be converted to acetaldehyde, a lot of it stays behind and reacts with acetaldehyde, forming something called an acetal, and it's what causes the second layer to form. This acetal formation is what makes everything so messy, as it directly reduces my yield, and I didn't know it at the time, but it will cause considerable pain later. Another painful thing about this whole process is that it just takes so goddamn long, since the reaction mixture can only absorb so much chlorine at a time. It's also not like I can just leave everything to work on its own and have to stand there and watch over this thing constantly, adjusting the chlorine flow and temperature so that the reaction goes fast but doesn't blow away all my product, changing the TCCA flasks or adding hydrochloric acid, and just generally looking out for any potential disaster. Speaking of that, over time, I began to really appreciate my gas scrubber, which tirelessly turned dozens of liters of hydrogen chloride gas, which is basically airborne hydrochloric acid, into harmless salt. Any unreacted chlorine coming over was also getting destroyed, turning into bleach, which gave everything this toxic green color. Anyway, after 5 hours, I went through only half of the TCCA, and there should now be mostly dichloroacetaldehyde present in the flask. To install the last chlorine atom and turn it into chloral, I had to really blast it. Luckily, as more chlorine is added, the boiling point of the mixture increases, as you can see on this beautiful chart, which means that I can set up a boiling water bath without having all my product magically disappear. At such high temperatures and under lots of chlorine, dichloroacetaldehyde basically goes through the 9 circles of hell and turns into chloral, as well as another portion of hydrogen chloride. To ensure that everything reacts, I had to stand there for another 5 hours and carefully watch this forbidden apple juice looking reaction mixture. The swimming pool smell in my lab also slowly got overshadowed by this weird, kind of fruity aroma. This was a good sign of progress, and after 10 hours the mixture officially stopped absorbing chlorine, taking on this aggressively yellow color. I couldn't believe that this nightmare was over, and I could now finally go about getting my well-deserved chloral. For that, I quickly removed the chlorine inlet, replacing it with a stopper, and got rid of the water bath to let everything cool down a little. I then began disassembling the setup, which was a journey in of itself, as I had to deal with a bunch of leftover chlorine. I bubbled it all through the gas scrubber, making what I call the salty bleach fountain of death. When everything finally calmed down, I was left with these 3 spent TCCA flasks still generating chlorine, albeit very slowly. This is literally active toxic waste, and since it will probably be weeks until it goes dormant, I decided to just stash everything on my porch and not worry about it. What I do have to worry about though is my product, since after the excitement of finishing the chlorination faded, I began wondering how I am going to get my chloral from this yellow mess containing a myriad of contaminants. A good bit of chloral is also present as the acetal, and I must somehow break it up to free my product. This is where I enter uncharted territory, as there isn't much info on this step anywhere, and I already failed it once. You see, thanks to a very generous professor at a local university, I was able to do a test run of the whole chlorination on a small scale a few months ago. It went pretty much exactly like this one, well, maybe except the part where most of my product magically evaporated. I distilled what remained with sulfuric acid to both break up the acetal and purify the chloral, which didn't really go as planned, resulting in this mystery syrup. That's why, despite already achieving so much in this run, I still wasn't sure I'd succeed, but as I don't have any alternatives to sulfuric acid, I whipped out a bottle of it and hoped for the best. To safely combine it with my product, I got the flask from before into a cold water bath and began adding roughly a third of its contents volume in concentrated sulfuric acid. The water bath will absorb any heat sulfuric acid likes to generate when mixed with virtually anything, and as the addition went on, everything began looking more and more like milk. I figured it's just the acid working its magic, and when it was all added and nothing looked like it's about to explode, I assembled the flask into a fractional distillation setup. It will allow me to separate all the components of my corrosive milk based on their boiling points. This setup is really the peak of amateur chemistry, including an expensive fractionating column, as well as a used vegetable oil bath, and your state-of-the-art cooked meat cans for stability. I honestly kind of thrive in this DIY chemistry survival setting, and as I began heating the flask, I expected a nice and smooth distillation. I couldn't be more wrong though, since as time went on, my forbidden milk began looking like caramel milk, and then more like caramel itself. Now, anywhere there is sulfuric acid and organic carbon atoms, there is always some tar forming, and this much still looked manageable, well, until it wasn't. Nonetheless, I tried to keep calm and even insulated everything with aluminum foil to help the column do its job, which is condensing and boiling the vapor many times over its large surface area, effectively separating its components into distinct fractions, which then condense and drip into the receiving flask. After a few minutes, something did manage to start coming over, and I thought that everything was fine after all, but then I glanced at the thermometer and started pondering. What chemical present here boils at 68 degrees Celsius? It's not ethanol, acetaldehyde, or any of the chlorinated acetaldehydes. It's also not any acetol. This was just weird, and I legitimately had no idea what I am distilling. I kept saying to myself, it's just some byproduct. I gotta be patient, the chloral will come over, it's just some minor issue. I even changed the collection flask when I noticed the temperature rising a little, hoping to get at least some product, but then the reaction mixture went full tar mode. If something goes full tar mode, you know you've officially messed up, and instead of some nice, clean chloral, I was left with this jiggly slab of acid gas emitting black tar. I had a hard time processing what the hell just happened and figured that the sulfuric acid must have gone rampant and somehow polymerized the acetals under heat. This definitely wasn't what Liebig advertised, and I originally thought that the acetal formation won't be an issue. However, 2 weeks of researching, buying supplies, and carrying out this godforsaken synthesis resulted only in tar and some unknown liquid. I still hoped that this stuff was at least part chloral, and to find out, I weighed it and added an appropriate amount of distilled water. It should react with chloral to form the hydrate, and if there is enough, it should solidify into nice crystals. Since I honestly expected nothing to happen, I didn't use a bigger container to hold the liquid, which surprisingly did end up reacting with water, heating up so much that it explosively boiled and confused me even more. I was plain mad at this point and honestly wanted to just leave all this, but instead ended up staying there for half an hour, tirelessly pipetting the quote-unquote chloral hydrate back into a beaker. I then got it into an ice bath to see if it freezes, which of course it didn't, ending up as the same thick syrup I got at the university. At this point I accepted that I utterly failed at this, got everything into a vial, and as it was nearly midnight, went to sleep. That night I actually dreamed about the synthesis, and when I woke up I had a few things to say.
Okay, so I thought about this a little, and first of all, freak you Liebig, I hate you and your synthesis. Also, yesterday when I pipetted the chloral, I was like, I'm never doing this again, and wanted to forget about this project altogether and just buy this stuff. But then I was like, nah, this isn't how I do things. So I decided to go for another chlorination, my way this time. Still, if it doesn't work, or if I don't finish it before the final exams I will soon be having, I'm dumping this project.
After realizing that the stakes are actually high this time, I sat down and thought about why this reaction failed me twice, and I think I finally figured it out. Starting from ethanol is just too dirty, preventing everything from fully chlorinating and resulting in too many byproducts, such as the acetals. The cursed sulfuric acid purification is also quite something, so at least on my scale, this route just ain't it. Now, what if I could avoid the acetal formation and using sulfuric acid altogether? Well, there is a way to do that, it's just incredibly hard. That's why I spent the next 2 weeks worth of free evenings gearing up again, cleaning glassware, buying and preparing more TCCA, making another C of the sodium hydroxide solution, investing in new cooling techniques, and assembling an upgraded version of the apparatus. During all this, I felt like Tony Stark in a cave making his first Iron Man suit out of nothing, as I was really pushing my garage's limits, trying to handle acetaldehyde. That's right, I figured that if ethanol is converted to it anyway, starting from it doesn't sound as crazy as before. Don't get me wrong, it's still crazy, and the only reason this bottle of acetaldehyde was shipped to me and hasn't exploded yet is that when I recorded this, it was freezing outside. Still, when I open it, everything will evaporate in like 5 minutes, which is why the new apparatus had to be even more chill than the old one. I mean, it's got everything. A random cloth? Check. Meters of aluminum foil? Check. Ice cold salt water bath? You bet. Hell, even the condenser water is isolated. Thanks to all these improvements, I was able to rapidly pour my 100 ml of acetaldehyde into the flask and seal it before it all evaporated. I then quickly started the chlorine flow, and yet again, a whole set of reactions began. They are nearly the same as before, but without the acetal formation and the first oxidation step, which allows me to use only 2 TCCA flasks. I also didn't bother with any antimony or other magic crap this time, since I am no longer trying to gently enhance the reaction, but simply brute force it. This also applies to the last chlorination step, since I think that I stopped the reaction too soon before, so I made sure to blast it to the moon this time. Even though I needed less chlorine and the mixture seems to absorb it faster, this chlorination took 13 hours, which was quite painful. Luckily, this time I remembered that caffeine exists and I must have drunk like 3 liters of my beloved Yorkshire Gold tea to stay sharp. When I was finally done, I once again let everything cool down and took apart the setup, leaving me with this thick, clear liquid. I also ended up with more toxic waste than I knew what to do with, as I barely managed to process the old one. Anyway, now's the time to distill my new mystery liquid, and since I wanted to do this right, I decided to carry out 2 distillations. The first is just a regular one, without any acid to mess things up, and it allowed me to get rid of any low boiling impurities. Then a miracle happened, since right as I swapped the receiving flask for a new one, this brownish liquid started coming over at pretty much the exact temperature chloral boils. I didn't want to get too excited just yet, but this was progress, and I distilled all of this stuff I could. I ended up with a decent bit, and I honestly thought there would be more, but the mixture in the boiling flask refused to give any extra product, and instead turned into tar, so I decided not to push it and got heavily confused yet again. Apart from the mysterious tar, this distillation went rather nicely and left me with these 2 fractions, with the darker one hopefully containing my precious chloral. It was now time to distill it all again, more carefully, and I also decided to do something about the acidic vapors my distillate constantly let off. This is probably hydrogen chloride left over after chlorination, and I found a really cool way to get rid of it. It involves the use of calcium carbonate, which is basically limestone, as it easily reacts with hydrogen chloride, neutralizing it and releasing carbon dioxide while doing nothing to chloral. To use it on my product, I decided to first combine the 2 fractions, as they are going to get separated again anyway, and together will give me more useful volume to work with. I then began dumping in some calcium carbonate, and at first it didn't seem like much was happening, but after a while the mixture turned into this nice show of tiny bubbles. After waiting a few minutes, I assembled this thing into a fractional distillation setup, using my trusty oil for the 3rd time now. As I began distilling this carbonated sleepy juice, some thick vapors began making their way up the column, and the first thing to come over was the low boiling junk. When it all came through, the temperature started steadily climbing, so I again replaced the receiving flask with a new one and began collecting something at around 95 degrees Celsius. This is exactly the boiling point range I would expect for chloral, so you can understand my excitement when this nice clear liquid started accumulating in the flask. When stuff in the boiling flask started tarring up more than I would like, I stopped the distillation and took apart the apparatus for what felt like the millionth time, and along with the low boiling stuff and tar, I was left with this beautiful transparent liquid. I was still hesitant about calling this thing chloral, but I figured I'd find out soon enough, since now it's time to hydrate it. For that, I weighed my product and calculated that I need to add this teeny tiny bit of distilled water for it to hydrate. I also decided to learn from my mistakes and do the whole thing in a flask with steering so that it doesn't blow up like before. As I began adding the water, everything started heating up quite a bit, which looked really promising. When all the water was added, I should now have just chloral hydrate in the flask, but deep down I still thought that this was going to end like before, and that when I cool it down, all I'll get will be some premium syrup. Nonetheless, with a heavy heart, I whipped out my ice bath, then plunged the flask into it, and after shaking it around for a bit, nothing happened. I wasn't ready to accept the thought of failing this for the third time, so I left this thing alone and instead went to make myself some tea. I then came back into my lab expecting the worst, but turns out the flask had a different story to tell.
Alright, so this has been sitting here for like half an hour, and now it's time for the moment of truth. No way! No way! No way! Look at this! We've got crystals! Yeah! Freaking hell yeah! I mean, this has to be chloral hydrate. There is no way that this is something else. This means that I've actually made chloral hydrate in this freaking garage. Yeah! God, I am freaking happy right now.
I was really surprised this worked, as it's proof I actually made chloral hydrate, and 2 months of work wasn't for nothing. This was quite the feeling, and after breaking up the big crystal slab, I was able to get everything out onto a dish. Now, excuse me for bragging, but these crystal chunks are just exquisite, being almost perfectly wide, big, and having that trademark smell. I decided to store them inside this antique amber glass bottle, both because it's fancy and will protect them from sunlight. I even made this cool little label and was just so thrilled about this actually happening. The only not so thrilling thing was the yield being 29.5 grams or a terrifying 10% from the starting acetaldehyde. This might just be the lowest quote-unquote successful yield on this channel, but you know what, I'll take it. It's still plenty to make DDT with. I really like how I managed to make this stuff despite literally every reaction not going according to plan, and in the end all that struggle and effort kind of feels meaningful and worthwhile. I mean, I learned a ton during this project and I hope you did too. Also, I want to officially come to terms with Liebig, because while I still think his synthesis is trash, this project wouldn't exist without him, and I think that it was the perfect showcase of chemistry as a whole. Chemistry is so much more than just boring textbooks and endless lectures, being both extremely difficult and unforgiving, but also fun and rewarding as hell, and I can't say I don't enjoy showing you all its wonders because it's just freaking beautiful. It's only thanks to you that I am able to do all these projects, and I especially want to thank all my supporters on Patreon for helping me stay afloat when YouTube randomly decides to delete my videos. Really, thank you guys. Anyway, see you in the next video. Wait, I haven't even started studying for the finals yet. They're in like a week.